Hi, this is Liu Yang from Beijing Normal University. In this video, I would like to introduce my latest work entitled Orbital-selective Mott phase of copper-substituted iron-based superconductors on an inhomogeneous three-orbital Hubbard model, which involves the degenerate XZ and YZ orbital and the XY orbital. The hopping terms were determined by the first principal calculation of the undoped iron-based compound, and the parameter of the intraorbital and interorbital interactions have been obtained by the best fitting of the Fermi surface with the experimental results of iron nictide. We studied the influence of the Hubbard coupling on the orbitally resolved density of state in the undoped case. The result shows that when the Hubbard coupling is very small, the system becomes a band insulator with a fully filled XZ and YZ orbitals, but an empty XY orbital, indicating that the electron prefers to occupy the orbitals of low energy. With the increase of the Hubbard coupling, all three orbitals become metallic, suggesting that the electron transfer from XZ and YZ orbitals to the empty XY orbital. Once J exceeds the critical value, the Mott transition happens in the XY orbital, while the XZ-YZ orbital remains metallic, leading to the orbital-selective Mott transition. In this paper, we focused on the cooperative effect of Hubbard coupling and impurity-induced disorder. The strong suppression on the density of state around Fermi level in the XZ-YZ orbital is observed, which is an evidence for the Anderson localization. Another interesting finding is that the substitution will induce in-gap state in the XY orbital when the system is in the orbital-selective Mott phase. By observing the real space fluctuation of charge density, we found that the occupancy of the XY orbital varied from half-filling and some discrete iron sites, which are indicated by the blue square in the figure above. As a result, local density of states of these points will be greatly changed. The Mott gap is replaced by a sharp peak near Fermi level, which forms the in-gap states in the density of state. It is worth to note that these in-gap states are all localized, which can be confirmed directly from its origin. We compile all our findings about the cooperative effects of the Hubbard coupling and the doping-induced disorder in a complete phase diagram that depends on substitution concentration and Hubbard coupling. We found an orbital-selective insulating phase, where the XZ-YZ orbital are Anderson localized, while the XY orbital is a Mott insulator. In addition, with the increase of doping concentration, the whole multi-orbital system will transfer from an orbital-selective insulator to an Anderson insulator due to the in-gap state in the Mott gap. Besides, you can find more interesting results in my paper, including the details of the real space Green function method and the model parameter of the three-orbital Hubbard model, and the physical mechanism for the orbital-selective Mott phase, and the real space distribution of a local density of state for certain disorder configuration. You're very welcome to read my paper, and thank you for your watching.